Well, welcome everybody. We are going to wait a couple of minutes so everybody can join the Zoom and the streaming, and then we will start the event. Okay, I think we are more or less all in, so we can start the webinar. So, well, welcome everyone to this second online event of the EHW. My name is Maria, and I'm part of the logistic committee of the event, and I will also be the moderator of this webinar. First of all, I would like to know if you can see my screen. Maybe Sid, you can confirm it, or Gregory.
Yes, we can, Maria. Thank you.
Thank you. Well, I would like to start by reminding you that this session is being recorded and broadcast live on our social media network. So if you don't want to be recorded during the session, you just can follow the event through our social media platforms, YouTube, Facebook, or Instagram. Also, a few small rules that will facilitate the development of the session. On the one hand, we ask you to please mute yourself and turn off your cameras during the whole session. Also, if you have any comments or questions, please comment on the chat, and when the time comes, we will answer your questions. If you can put your name and the team you belong to when you ask something or when you comment something, we will also appreciate it. So also, if you are following this session on streaming, you can also make questions and we will answer them. And if some questions still don't be answered during the event, we will include them on our website. So just after the event, you will have the answer. The schedule we will follow during the event will be as follows. First, our colleague Gregory will give an introductory talk with some news about the event. Then we will have the pleasure to have the conference of our main sponsors, first Celeros, then Novomo, Virgin Hyperloop, and Aecom. And then a brief introduction to the speakers we are going to have here today. Well, we have from Novomo Shenislav, that is the CEO and co-founder of the company. From Celeros, we have Juan Vicen, who is the co-founder and chief marketing officer. From Aecom, we will have two speakers, Walter, who is the program manager, and Kawa, the manager of transit planning and engineering. And then last but not least, from Virgin Hyperloop, we will have Diana, who is the senior director of global alliances and policy. So, well, it's a pleasure to have all the speakers here with us and also to have all your attention as attendance. So I'm going to give way to my partner, Gregory, and stop speaking. So thank you so much.
Thanks, Maria. Hello, everyone. My name is Gregory Dio, and I work on the logistics and technical aspects of EHW. I'm going to start off today's webinar with updates about EHW 2021, including the health situation, venues, and official dates of the event. So first, starting with the health situation, we are currently checking local restrictions of registered teams, such as access to on-campus activities, movement restrictions, and international travel restrictions. And we wish that all the teams are in good health, and I hope you are in high spirits during your work and studies during these times. I encourage you to stay optimistic like myself, and I insist that we are aware of the health crisis and are studying it closely. And on the slide now, you will see that the 24 teams from across the world who have passed the first stage and intend to participate in EHW this summer, and we are excited to have them all here with us. So with some news about European Hyperloop Week, the European Hyperloop Week 2021 will start on Monday, the 19th of July, 2021, with an opening ceremony, tour of the venues, and mingling between all the teams and participants, and it will last through Sunday, the 25th of July. As previously mentioned, we are monitoring the health situation carefully, and especially as we get closer to the event. So EHW 2021 will begin at the UPV campus with the penultimate day, Saturday, the 24th of July, taking place at Circuit, where the complete pods will be showcased and demonstrated at the UPV test track for the Complete Pod Award. Each day will have a specific theme with conferences and other networking activities paired with the awards of the design competition, as you can see on the schedule on the slide right now. Sunday, the 25th of July, will be the day to finally bring together the companies, individuals, and students who have participated in the event. And it will be a day full of surprises, and we will be unraveling these throughout the coming months. I hope you are all just as excited as myself. Thank you, and I will pass it back to Maria now.
Well, thank you so much, Gregory. Hopefully this introductory talk has helped the rest of the teams to have a better idea of what we are doing during the event. Now I'm going to give way to the first conference that is going to be given by Juan Vicen from Celeros. So, well, Juan Vicen, welcome. I'm going to stop sharing my screen so you are able to share your screen. Thank you.
All right, thank you very much, Maria, for this introduction. I'm going to share my screen now. Please confirm that you can hear me properly.
Yeah, we can do it. Thank you.
Perfect, thank you. So, well, it's a pleasure to be here. My name is Juan Vicen, and I am the co-founder and chief marketing officer at Celeros Hyperloop. We are the Spanish company developing a Hyperloop system that is scalable for long distances, which is where we think that is the best case for Hyperloop. And I'm going to start by explaining a bit more about what is Hyperloop. Sometimes, well, we are in a Hyperloop event. We already, most of us know about Hyperloop, but well, we had discussions with many Hyperloop promoters, different companies, and basically we can summarize that Hyperloop. It's not something that is clear for everyone, know what it is, but at least one description would be that it's a guided ground transport system, similar to railway in that sense, that it can offer high speeds up to 1,200 kilometers with high energy efficiency and zero direct emissions. Most of the concepts are fully electric, but we have also hydrogen systems that are being considered. On the other side, we have high capacities. We are going to compete against airlines, for example, that have that are in the range of distances where Hyperloop has, and the system needs to be competitive with this. No? So that's why it's needed 50 to 200 passengers is more or less the range for capsules departing every 2 to 5 minutes. And also it's an efficient, it connects efficiently the inland hubs up to 500 kilometers away. This doesn't mean that for low distances or for very high distances, it doesn't make sense. It's also a good option, but the optimal distances are between 400 and 1,500 kilometers from our view. We always say that this is not something new. There were already designs of Hyperloop systems 200 years ago, where for example, in UK, they were trying to go from London to India and bring some species. Well, of course, that was just a dream, but there were some prototypes also, first in UK, then United States, with some pneumatic propulsion systems. But then later they discovered the energy needed to evacuate the tubes, where the technology was not ready at the time. So then in Russia, they started thinking about magnetic propulsion to move the capsules inside the vehicles. And then in France, there was the invention of the linear motor in order to propel also the capsules. Then we saw the advancements in superconducting magnetic levitation that gave birth to the Japanese concept, and also in Germany a different concept, the electromagnetic suspension, that gave birth to the Transrapid, which is now implemented in China, working at 430 kilometers per hour, and also the Japanese concept that has the world speed record at 300 kilometers per hour. But the thing is that the technology at that time was not ready, and so why Hyperloop can be a reality right now? So the main things, the first one is because the world needs decarbonization. I think it's clear. Climate change, it's a big problem, and all the governments are trying to look for sustainable ways of reducing the carbon emissions. On the other side, cities are getting crowded, so people tend to go to the cities to live, and this is going to have some needs for mobility, new mobility means that can alleviate these needs. And on the other side, air traffic saturation and green investment commitments. No? So governments are investing in new technologies, green technologies such as Hyperloop. The other factor is technology readiness. The technology 200 years ago was not ready, but as of now, we are talking about large volume pressure systems. We are talking about high pressure, high frequency automation. We are bringing, we are launching rockets and bringing it back to Earth. And in that sense, technology is now ready for Hyperloop. In that sense, in 2013, you already know, Elon Musk popularized this Hyperloop concept, and we participated as a university team as a university team from Valencia in the competition from Elon Musk, winning the top design and best propulsion system awards in 2016. Since then, the Hyperloop team at the University of Valencia has been evolving. There have been different prototypes created for the competition with very good awards, and I'm very glad to see that you are promoting now this European Hyperloop Week together with the international colleagues. It's just to mark that the university team has been progressing, but we thought we needed to create also a company in order to realize and make a commercial system. And that's why in 2016, we created the company, Celeros, to make it a reality. Since then, we have evolved quite quickly. Right now, we are 35 people with a core team here in Valencia, but also 20 people in Altran who are also supporting. We have raised investments, and we have a unique innovation environment here in Valencia and our partners that make us, we are growing quite fast in that sense. No. Here, just so you have some overview of all the people involved, we have more than 150 people involved in the development, with leading investors like Red Electrica, which is an energy TSO, plug and play from Silicon Valley, Altran from France. And then we have research centers that are also like leaders in, for example, in magnetic levitation, like CMAT, or partners like Renfe, who are operating the high-speed rails in Spain. No? This, together also with institutional support and several projects that we have launched together with governments, makes us to stay at the forefront of these developments. And I wanted to highlight you that in the end, we are not alone. You can see it also in this conversation. There are different Hyperloop companies, not only companies, but also governments, such as the Chinese and the Korean government, are involved in Hyperloop development. And this makes the project even more exciting for us. No? In that sense, our question always is convergence possible? So there are different concepts. We are creating a system that is for cross borders. So we are trying to bring closer together the cities. But what happens if we have different systems that cannot be interconnected? In that sense, we have analyzed all these parameters that affect the possibility of convergence, and is what I wanted to highlight to you in this presentation. The key parameters are highlighted here as a summary: the pressure levels, the heat dissipation, the blockage ratio, the propulsion systems, levitation systems, power and energy, braking, and communications. And I will do a brief summary of each of them so you understand what's driving us in order to achieve the most scalable system. The pressure levels is one of the most known aspects. We have here a graph that shows a bit the different options that are right now. Basically, we have mid-pressure Hyperloops, is what we call aviation-like. It's the Hyperloops that operate at similar pressure than aviations or airplanes. In that sense, it's about 100 millibars as a reference pressure. And then there are other solutions that are at what we call ultra low pressure or space-like. And these concepts, they have pressures more similar to space, and they have different requirements. Just as a reference, we have here the example of a fighter jet crew, which need to bring a pressurized suit in order to drive the vehicle. And on the other side, the Concorde crew, which was operating, it's a supersonic airplane that was at similar pressure levels than that Hyperloop, where crew didn't have to wear any new safety measures. In that sense, pressure levels have an influence in the severity of cabin to tube breach. So it's not the same as having a breach in the vehicle if it's a low pressure gap or a high pressure gap. No? So the lower the pressure gap, the easier the repressurization in case of evacuation or a pressure breach. That happens the same also in the tube. If you have a breach in the tube, then the lower the pressure gap, it's the easier to repressurize the system. Because also there are some pressure waves that might occur in this case, no? And for that, you can have different ways of reducing the complexity. Regarding the pumping complexity, it's more or less the same. No? If you have to go at a low pressure gap, then you don't need a very complex pumping system. For example, with single stage pumps located every 10 to 15 kilometers, you can have your system operating with the pressure maintained. But if you need to go at much lower pressures, then like space pressures, you need a bit more complex pumps. No? On the other side, the pressure levels also have an influence on the tube thickness and the pylons. It's not the same as maintaining the pressure with aviation pressures than in space pressures. Obviously, for much lower pressures, you need not only different materials, but also you need much more thickness, not for the tube, and this also have an influence on the cost of the system. And then we turn to heat dissipation. You know that at low pressure, heat dissipation starts being a problem, no? And that's in that sense. Of course, there are different effects. No, if you are working at aviation pressures, you have it's easier to have more thermal dissipation. If you are working at space pressures, then it's more difficult. It becomes a challenge. So that turns into in the end, if you have lower pressure gap, you need lower energy consumption to maintain the pressure. No? On the other side, I wanted to talk about the blockage ratio. It might be maybe too technical, but mainly it's about talking about if you have a system, a tube and a vehicle, if you have a compressor system in the vehicle, then you don't need to, for the same pressure, you don't need to make the vehicle, the tube very big in order to avoid the blockage of the vehicle traveling at that high speeds, no? Whereas if you don't have a compressor in the front, then you need to make the tube quite big in order to avoid these issues, no? This increases, of course, the cost. One option could be, okay, why if we reduce the pressure so that we don't have these issues, no? So then you can turn it to the space-like pressures where you don't need maybe a compressor, but in the end, you need to reduce a lot the pressure and the cost of infrastructure. In the end, you don't have to increase the diameter, but you have a cost increase in the pressurization system because it needs to be, as I said, the pumping system needs to be different. So on the propulsion system, it's also about having the propulsion in the vehicle or having the propulsion in the truck. If you have the propulsion in the vehicle, you need some way of power that powers this propulsion in the vehicle, no? But on the other side, you reduce the cost of infrastructure. In the case of the propulsion in the truck, you need power all along the track in order to make the vehicle move. So it's a decentralized system. It's more difficult yeah, you need power all along there. So that means a high infrastructure cost. Then we go to the levitation system. You know that there are active levitation systems and passive levitation systems. In the case of active, you are attracting to a steel plate, for example. And this, of course, is like the Transrapid. You need a complex control to maintain a constant gap. But on the other side, you have a light power system, so you don't. It's not that heavy consumption. But on the other side, you also have low infrastructure cost because the steel of the tube can be used for levitating. In the case of passive levitation, then you need to have or copper or aluminum in the track, and this increases the infrastructure costs. On the other side, you don't need complex control, so that's an advantage. But then, if you need to put coils or magnets all along the track, the infrastructure cost yeah, it's higher. Plus the magnetic resistance, which is something that is very difficult to avoid in case of passive levitation. In terms of energy or power, if you can have the power on board or the power on the track that is giving power transmission to the vehicle. Obviously, for the vehicle, the most efficient way is to have the power on board. No? This means a heavier onboard storage, but on the other side, you make sure that the vehicle is self-reliant, so it can move autonomously. And on the other side, you don't have that high infrastructure cost to electrify the whole track. But if you have power on the track, you have a lighter onboard storage. But on the other side, you need to rely on the track to move, and you have high infrastructure cost for the electrification. Regarding the braking system, if you have the systems in the vehicle, you can have an aerodynamic braking, you can have a magnetic braking. In that sense, for example, the aerodynamic braking has some complex control, but then it has a low infrastructure cost, no? Whereas if you can have also the braking system in the track that it can be the same as the propulsion one with some linear motors, but then you can have also this infrastructure cost that you need in order to be able to brake at any situation at any time. And for both solutions, energy regeneration is possible. So that's one option. And regarding finally the communications, I wanted to highlight that in Hyperloop you have high speeds like an airplane, but it's a guided system. In that sense, of course, you cannot use the GPS, the satellite communications. It's very difficult because you are inside a low pressure environment, inside shielded with metal. So in that sense, it could be more similar to kind of the ERTMS. It's an example of railway interoperability. There could be kind of a Hyperloop ERTMS, which is something that we consider that could be very interesting. So in summary, we think that working at aviation pressure levels, which are like medium pressure Hyperloop, instead of space pressure levels, has a number of advantages regarding safety and marketability, not only because of the safety, but also you can achieve with commercial systems that are already on the market a Hyperloop. And on the other side, taking into account that the 95% of the cost of a Hyperloop project is the infrastructure, we think it makes sense to integrate the most of the systems we can in the vehicle to minimize the infrastructure complexity. So we think this is needed in order to achieve the long distance routes. So now that I have some kind of summary, I will explain basically our Hyperloop system. At Celeros, we are developing a system based on this analysis that can have the main propulsion and levitation systems in the vehicle. And this has an advantage in using safe pressure levels, reducing infrastructure cost of construction, operation, and maintenance. And on the other side, it can have it is one of the systems of Hyperloop that has a higher capacity in the vehicle capsules, reaching up to 200 passengers. From that point of view, we are competing. We have similar capacity than an airplane, but we are consuming 5 to 10 times less. So, and with zero direct emissions. So this is a big advantage for a European Hyperloop, for example. In terms of minimization of infrastructure cost, you can see the system on the left is the Celeros one, which just needs a boost at the beginning in order to reach the destination autonomously with the vehicle, whereas some other systems need to have a complex infrastructure. Regarding the cost, as we have all the systems in the vehicle, we try to be more on the side of high-speed rail rather than other systems that are more similar to maglev-based coasts, which have a very high cost in infrastructure, and that makes this is a problem for doing long-distance routes where Hyperloop makes the most sense, in our opinion. Regarding the safe pressure levels, I already talked about that, but you have an accelerated path to market. You can use common safety systems such as in airplanes. And on the other side, basically, it's a matter of cost. No, basically, going at aviation pressure levels in terms of cost makes sense. Regarding technology development, we started with the first phase, that is the laboratory subsystem demonstration. We have been carrying out since the very beginning at Celeros. And the next step is the development of a medium scale demonstrator. It's already ongoing. And the objective is to test it in a high-speed test track in Spain, where we are already promoting the creation of a European Hyperloop Development Center. In this space, we plan to demonstrate all the critical technologies for Hyperloop at high speeds, which we think is the biggest challenge of Hyperloop, no? Demonstrate that all technologies work together. And the next step would be, with this in mind and with all the cost and all the certification of all the performance of the system, to create a real size Hyperloop system. And this will come, of course, with the support of countries such as the European Union or other countries worldwide. We are already working on different routes analysis of different countries in the world that can be benefit. And just to give you the latest updates on Hyperloop standards and regulations, it's a good moment for Hyperloop. I can summarize. In 2018, we signed the first agreement to cooperate on Hyperloop regulations. Since then, the European Commission, the DG Move, and Shift2Rail decided to create periodic meetings for Hyperloop with the different Hyperloop promoters. And then the regulators like EASA and ERA started to join the debate together with other parts of the European Commission. In February of this last year, we created successfully, with the support of all the countries, the first standardization committee in Europe, which is the world's first, that will take care of the standardization of Hyperloop. And then this last year, there were the Euro Parliament trying to include Hyperloop on the post-COVID recovery plans, the start of a regulatory study on Hyperloop at the European Commission level, and also Hyperloop is on the agenda of the climate sustainable mobility strategy in Europe. Finally, HyperNext is the first project funded by Shift2Rail to work on Hyperloop. There are different universities taking part, also Hyperloop promoters, and it's coordinated by the Technical University of Madrid. And this is going to be a very, very good message once it finishes at the December next year for Hyperloop in Europe. I finally wanted to highlight that Spain is pioneering the Hyperloop development. Spain, in the end, is a reference in high-speed transport. The chairman of this standard committee is Jaime Tamarit. He's an expert in maglev and ERTMS systems. Also, Spain has a reference laboratory in interoperability. It's operated by CEDEX. And also the different platforms in Spain, like the railway, aviation, and infrastructure platforms, are taking part with an ecosystem of industrial players. Celeros has a solution in Spain that can be scalable, and we are demonstrating that can be the most scalable solution. And finally, Valencia is going to be holding, and I'm very glad to see that, the first European Hyperloop Week. So all in all, we think that Spain is going to be one of the reference countries, together with all of these ones that are already involved here for Hyperloop development in Europe. And this is also very aligned with the Sustainable Development Goals of Europe. Just to give you an example, for a scenario in Europe, we could avoid up to 30 million tons of CO2 per year, and a lot of millions of hours saved by travelers, with a very high economic impact. So this is our vision, to connect the world in a matter of minutes. And I thank you very much for this opportunity to showcase our project here in the European Hyperloop Week as a live event. And if you have any questions, please do not hesitate to connect with me later.
Well, thank you so much, Juan. It has been a really interesting presentation. We have some questions from the chat and also from Instagram. So I will ask you. Well, from Javier, who is following the webinar from YouTube, we have a really long question, so I'm going to read. Well, he say, I followed you since the very beginning when you were proposing to levitate from the top and using a compressor on board, and I firstly thought you were crazy. But then the Elon Musk award came in, you built some prototypes, and now I even see some competitors following this same principle. How are you so convinced that this is the most scalable way?
Well, this is a good question. Basically, when we started developing our Hyperloop idea, we were just seeing what the other, like the different organizations were doing. We saw that the concept of Elon Musk was levitating through from the bottom, and then we see that if you can hang from the top, you have a number of advantages. Also, you could even do kind of a balance during when you need to turn. So basically, this made us think that we should create some theoretical deep analysis on the topic. We created this virtual model of the system, and realized that in terms of infrastructure cost, that could be the best solution, and that infrastructure cost is in fact a critical aspect in this project. So, well, we are on the way to demonstrate this with our prototypes, of course, and well, we are just, we are not crossing fingers. We know this can be a solution, and that's why we are evolving so fast.
Okay, so thank you so much, Juan. We are going to pass to the next conference, and we have a little more questions, but we will try to answer them during the final section of the event. So now I'm going to give pass to Novomo. That is the next company to present. So I'm going to let you present. Thank you.
Okay. Hello. Hello, everyone. Thank you for having us. Thank you, Juan, for an interesting presentation just before. Let me just share the screen with you, and we can start. Sorry. Okay, works. Is the screen okay? Can you see it?
Yeah, we can see it.
Okay, great. So let me start. So sorry for this issue. Okay, so thank you so much. My name is Przemek Pączek. I'm the CEO and co-founder of Novomo, formerly known as Hyper Poland. And today I would like to say a couple of words about what we do and how our approach can help to find a way how to transform existing railways into a much more efficient system, which will be interoperable with Hyperloop. So as I said, we started as Hyper Poland some time ago. Now we are Novomo, and our main mission is to create this bridge of interoperability between conventional railways and the Hyperloop. We are aware that it might seem a bit crazy that old railways can change so much, but I will try to explain in a moment how this could happen. So of course, main strategic directions we follow are digitalization of railways, especially the infrastructure part, which is very analog and it basically hasn't changed for the last 200 years. We are absolutely focused on a couple of core technologies, which are propulsion, suspension, and power electronics systems. This is where we feel most comfortable, and this is what we do. Of course, we support what was already said by Juan, modal shifts from road and air. This is a must if we want to protect our planet. And something which we believe is quite critical is the idea of unlocking the full economic value of the existing railway lines, especially the land beneath them, because they have unique locations, they access dense city centers, and this land can be utilized in a much more efficient way. So just a few points in time, visualizing our development. The very initial origins were in 2015, a student team at the Warsaw University of Technology taking part in Elon Musk's space competitions. Then we incorporated in 2017. 2019 was quite critical. We secured first funding and presented the first prototype of our linear motor and magnetic levitation. And in 2020, quite a lot of more commercial advancements in Hyperloop to some extent, and in the MagRail segment, which I will explain in a second. The team is based in Warsaw and Berlin. It's a mix of business development and technical skills, especially a lot of experience in infrastructure design and construction. The technology team is mostly based in Warsaw, but we have also some experts working with us remotely. For example, Johannes Braun, who was responsible for building the Shanghai maglev, who is our advisor. We used to work also with Professor Geras from the US, one of the best experts in electromagnetism globally. The rest of the technical team is mostly PhDs from Warsaw University of Technology, and the business development team also a mix of experience in the railways, airlines, energy sector, investment banking, and we have a couple of advisors which are spread among different locations, mostly in Europe and in Israel. And now a bit more on what we do. So I would like to start with a bit broader picture of where we believe modes of transport are, and especially the railways. And in our opinion, they are in quite a particular moment in their history, which will be quite decisive on their fate in the coming decades. We see some analogies with the automotive industry, which around 20 years ago started some major shifts like electrification or emergence of autonomous vehicles. And now we strongly believe that existing railways will be much more pressured by new modes of transport, such as Hyperloop and other ones, and they need to find a way how to modernize themselves in order not to become more marginalized, but rather plug into this new development, new technologies, and because they have a lot of assets which they can use, but they need to move faster and become much more adapted to what's happening. That's why we propose a stepwise approach to Hyperloop implementation, starting with phase one, which is called MagRail. It's a combination of a conventional railway track with an addition of linear motor in between the conventional rails, and magnetic tracks on both sides, everything attached to sleepers. This is a way cheaper solution than building conventional high-speed railway lines. And the biggest advantage is that it has quite a lot of things in common with Hyperloop. So the propulsion and levitation systems might become compatible with Hyperloop. Of course, it depends on the final choices for Hyperloop, and Juan has talked about it. And we also have technology allowing subsequent transformation of such MagRail corridors into a full Hyperloop solution. So from our perspective, phase two Hyperloop can be either done as an upgrade from MagRail or as a new corridor developed from scratch. We are aware that it's going to take quite a lot of time to build a full pan-European Hyperloop network. That's why we believe that this MagRail can be a major step forward, allowing some shifts already to happen. And interoperability is absolutely critical here. We would like to avoid the scenario where maglev implementations didn't proliferate at scale and didn't create a network effect, and our MagRail is just something in between conventional railways and Hyperloop. That's why we believe it's critical to have it also for this transition period dilemma, which always, creates some issues, whether what should be first, infrastructure, vehicles, existing systems, how they should be used, and so on. And from the technical point of view, you can see how more or less a MagRail looks like. So we have sleepers, conventional rails, linear motor as a third rail in between, and magnetic tracks on both sides. So you can basically use the same line for conventional trains on wheels, but also magnetic vehicles. Then you can, of course, also enclose it, cover it, so you can have something that resembles a Hyperloop much more, of course, without the possibility of using conventional rolling stock anymore. It's much cheaper than building new high-speed lines. Our cost estimates are around 6 to 8 million euros per kilometer, while a new high-speed railway line costs at least 20, sometimes even much more. Also, the operational costs are expected to be much lower. because everything becomes frictionless and digitalized, it's also much more efficient in the operations. From the operations point of view, that's why we think that we don't treat Magrail as an alternative to Hyperloop, but something that can be developed and implemented quicker. Probably instead of about 10 years, five should be enough to have first implementations. And this is also something that will allow new Hyperloop to emerge faster, because many components used in Magrail will be also later used in Hyperloop. We have a couple of interesting partnerships and cooperations. We work together with Aecom, a leading Spanish consultancy designing railways or doing feasibility studies. We are also part of this Shift to Rail HyperNext project, which Juan has mentioned. And recently we have joined the Dutch Hyperloop development program, where our responsibility is to design power electronics components. And currently we are in talks with a couple of leading European infrastructure managers concerning Magrail. First agreements should be signed in the next in the next quarter. Yeah, we talk with a couple of others with different potential use cases, which you can see on the screen. So either high-speed lines, closed line reactivations, airport to city center connections, regional lines. There's quite a lot of these. And in Hyperloop, as I've said, we started cooperating in the Dutch Hyperloop Hyperloop development program, but we are more than happy to provide our expertise in power electronics and linear motion, so the linear motors and magnetic levitations, to the whole Hyperloop ecosystem to facilitate its growth. Also, as I've said, taking into consideration the fact that these components will be firstly tested in Magrail, so there will be a lot of references and history to support their implementation in Hyperloop, proving that they are safe. So I think that will be it from my side. Thank you so much. If there are any questions, happy to answer them.
Thank you so much for this presentation. We have several questions. I'm going to ask you one of them, and at the end of the session, we will ask more.
Okay.
So from Gregory, he wants to know, how is Novomo collaborating with current railway companies to mitigate the risk of pushback if Novomo proposes to utilize existing rail infrastructure for the implementation of Hyperloop?
I didn't exactly get the question. What does Gregory mean by pushback? So maybe we could get back to it later, unless we can have some clarification now.
Okay. Well, in fact, we have more questions, and I can ask you other one. Or maybe Gregory is here, so I don't know if he wants to.
Or Gregory, if you could, yeah, clarify, because I'm not sure.
Well, Gregory?
Yes, so you mentioned...
Hi.
Hi, yes. So you mentioned the utilizing the existing rail infrastructure as part of your presentation. I was just wondering how railway companies are responding to that, if of course we're working towards a transition from...
Yeah, you know, it's quite different, depending a lot on geography. So we have quite a lot of talks happening at the same time in Europe. In some parts of our continent, the response is rather not very in favor. In others, it's super enthusiastic. So it's it's extremely mixed, the approach for the moment, but we see more and more infrastructure managers getting seriously interested. Of course, having, you know, a next generation of prototypes with which we are testing now helps a lot, because they can see in more details how the system can work. So in one sentence, the approach is extremely mixed. There are big enthusiasts and there are super haters. So it's really not one approach for the infrastructure managers as such. I hope it answers your question.
Yes, it does. Okay, thank you.
Gregory, you have made a really hard question, but thank you for answering it. And now I'm going to give pass to Virgin Hyperloop, to Diana. So thank you again, and
thank you so much,
and welcome to Virgin Hyperloop.
Hi, everyone. It's great to be here today. Thanks so much for hosting us. We're really excited to share the stage with so many Hyperloop companies and folks who are working on developing the Hyperloop technology. I'm going to just share my screen. Apologies. Give me 1 second. And oh, there we go. Let's see if this works. Oh, okay, there we go. My name is Diana Zhao. I'm our Senior Director of Global Alliances and Policy. I cover a lot of our commercial partnerships and various projects, especially in Europe, but also around the world. And I also cover our policy and various regulatory initiatives, a lot of which you've actually heard earlier today from Celeros and also from Novomo about the various European Union initiatives and programs that are going on at this moment, including a lot of work around standards, around incorporating Hyperloop into something as impactful as the European Commission's smart and sustainable mobility strategy, which is incredible. And we're really excited to be such a large part of what is going on today around Hyperloop. I'll introduce the company and spend most of my presentation actually talking about what we've done and what we've developed from a technology perspective. You've all heard already about Hyperloop and what it is. I'm sure you guys are all here because you're very familiar with the technology and the work that's been done so far. But a little bit about Virgin Hyperloop. First of all, we have over 500 plus tests now completed at our DevLoop site, which is in outside of Las Vegas in Nevada. It's a test site that we've built in 2016 and started testing on in 2017. As of right now, we have over 500 tests completed. It's roughly 500 meters long. It's a full-scale Hyperloop system. So that includes the tube, our levitation, our propulsion systems. It is in a vacuum chamber, actually the third largest vacuum chamber in the world today. And we've continuously been doing testing on it since 2017, since the middle of 2017. We are a company that is based out of Los Angeles. That's where our headquarters are, where we have over 300 employees. We also have a small office in Dubai with about 10 or 12 employees. And we have various projects and various conversations going on with a number of different transportation departments around the world. We have, at the heart of it all is our intellectual property. We have over 200 patent applications currently protecting our intellectual property. And that's a very important part of the company. And to date, of course, we wouldn't be able to do this all without funding. We are privately funded. We've raised over $400 million in funding to date through a series of rounds, private investment rounds. It's actually really incredible to see how far the company has come in the last 7 years. I joined the company about 5 years ago now, and we were in a very different place, as you can imagine. We started in 2014, literally in a garage, in a way that you hear about a lot of Silicon Valley, West Coast, California companies starting in a garage. We were literally there 7 years ago in a small garage. What you see here in this picture is actually Josh Geigel, our co-founder and CTO, looking very frustrated at some of the work that we were doing back then. And we started raising funds even then in 2015 and later to start developing a lot of the technology. At the core of it all, what we believe in is that the faster we can develop the technology, the more we can test the technology, the faster we can get to market. And ultimately, a lot of this is what the company has been based on. So it's not just on the pure theoretical analysis, but we really believe that in order to know what works best, from a system perspective, we really need to build it and we need to continue testing on it, which is why we've focused on building DevLoop. Even before that, we built our first propulsion open air test, which you see here in 2015, and in 2016, we tested the first system, our first propulsion system ever in 2016, which was a success. And later that year, we started building DevLoop, which I mentioned earlier is the 500-meter test site in the desert outside of Las Vegas. We did our first full-scale system test in the summer of 2017, continuously ramping up the speed of that test until we got up to 387 kilometers per hour in that short 500-meter. So we went from 0 to 387 kilometers and back down to 0 again. So it's quite short. And obviously the acceleration and deceleration rates for that test were very large, and we did not subject passengers to that when we did our passenger test just a few months ago. We have now since moved to a new system architecture. So we've actually moved on to our second generation system. We started doing that after our various tests in 2017. We've also had our system and our technology verified by a third-party aerospace corporation. We believe that the complexity of the system and the work that we're doing is very complicated, and it's very new. And having that validation by somebody external to the company that had a lot of experience, not just in aerospace, but in many different industries that were relevant to Hyperloop, was really important to us to confirm that the work that we're doing is actually something that is, it is valid and achievable. What you see here at the top is our first concrete constructed tube. So as I mentioned before, we had a lot of learnings when we built DevLoop, and that has led to the release of our new commercial system. But one of the really important things that we learned as we built this full scale 500-meter steel tube was that it was very difficult, in fact, to get the weldings between the tube sections just right because of the way the steel structure behaved. And so we've actually migrated a lot from that and looked at different composite materials. We looked at different options when it comes to the materials of the tube and how it could seal the vacuum. And we've decided to look at concrete. And so this is a picture of one of our test rigs, one of our concrete test rigs. In 2020, in November of 2020, we had a very exciting announcement where we had the world's first Hyperloop passenger test on a system that was certified by an independent safety assessor named Certifer. And I'll talk a little bit more about that in one of the subsequent slides. Also in 2020, another really exciting thing for us and for the rest of the industry, in fact, was that Hyperloop was recognized as a transportation mode by the US Department of Transportation. This is really an incredible milestone, I think, for the industry. It really puts us on the map, Hyperloop on the map, not just as a research and development project, but as a real mode of transportation. So what this does is it validates the technology, it validates that there's a market for it, that there's also a path to certification. One of the really important things in this document was that it named the Federal Rail Administration, the FRA, as the regulator for Hyperloop. So right now, all of the questions that we may have as we're developing the system around safety, around compliance, around the pathway to certification, there is a home for that. And there is a place where within the Department of Transportation that we can go to for answers to those questions. We could not do this alone as a company. I mentioned that we are 300 people large, but when it comes to building big projects, big infrastructure and technology projects like this, we have partnered with some of the largest companies in this space, some of the biggest, most forward-thinking partners in transportation and logistics, and their experience and their history has actually helped us tremendously when it comes to developing and deploying this technology. One of our biggest investors is DP World, Dubai Ports World. They own and operate over 70 ports around the world, and they are a huge player when it comes to global logistics. Also, the Virgin Group is one of our major partners, especially when it comes to the passenger experience, which you'll see a little bit later in our videos that actually the way we've thought about what the passenger experience looks like, what it feels like, even what it smells like is very much in line with the Virgin brand, and we take a lot of our cues from how they've thought through the passenger experience. And of course, some of the other big players that we've worked with, Spirit Aerosystems, which is a large provider of airplane fuselages for Boeing and other companies as well. Fluor, which is a huge construction firm based in Texas, SNCF in Europe, the French railway company, and other design and architecture firms like BIG. These are all big partners of ours that we've worked with quite a bit. As I mentioned earlier, we had a really, really exciting milestone just a few months ago. On November 8th, the first passengers ever traveled safely on a Hyperloop. What you see here on this slide is a very excited Josh Geigel, our co-founder and CTO, along with Sarah Lukian, who is our director and head of the passenger experience. They were the first two people to ride on a Hyperloop. It was really a culmination of years of effort to come to this, to build a system, to build a pod that can not only move extremely fast, but also safely for people, for passengers. This was a two-seater prototype vehicle, and it demonstrated many Hyperloop safety critical systems. You'll see here that the pod speed is not actually our top speed. 48 meters per second translates to just over 170 kilometers per hour. But the real purpose of this test was actually to prove that we could do it safely, and we can bring those people back safely. And so I can guarantee to you that Sarah and Josh are still with us today and still in very high spirits. And this was and showing that we could do this without requiring them for example, to wear spacesuits or anything that would be an inconvenience was something that was really important to us. This was a process that that took a long time because we wanted to do it right. We could have probably done it earlier, but we wanted to make sure that as we are building the first new mode of transportation in over 100 years, that we had safety absolutely at the forefront. And so because of that, we worked very closely with an independent safety assessor, a firm named Certifer, which is very well known and very well respected, especially in the rail area, based out of France. We worked very closely with this ISA in order to safely assess our system. I will now show a brief video. Please let me know if the sound does not come on.
We're driven to explore, to connect, to innovate, to muster the courage to take a giant leap forward. The time has come to ask ourselves again, what is the future we want to build?
All right, team, please confirm you're ready.
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 Capcom, you are a go for launch countdown.
Pegasus, this is Capcom. Prepare for launch in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, launch.
Today, the first people traveled safely on a Hyperloop. Tomorrow, Virgin Hyperloop will change the way the world moves with an on-demand, sustainable mass transportation system that connects cities in minutes. The future of Hyperloop travel is real, and the moment is now.
It gives me goosebumps every time I watch that video. It was such an exciting moment for us. And I was actually part of the group that was at DevLoop at the time when that happened. I saw them coming out of the pod afterwards, and it was just really incredible for us as a company, to have achieved that milestone. What we've done since then, you may have seen that we released a really exciting rendering of our passenger experience in the interiors of our pod just a few weeks ago. What you see here is actually a rendering that we designed with a couple of design firms, Teague as well as Bjerke Engels Group, around how the passenger experience will look like. The interior of our pod fits up to 28 passengers comfortably. So you see here that the way we thought about it is a 2x1 configuration. When a lot of people think about the future and Hyperloop being a futuristic mode of transport, though I would argue that actually it is the present and the now, sometimes there is this dystopian feel, a lot of dark colors, a lot of chaos. And what we've tried to do is actually create something here that is very calming, that is green, that shows hope and optimism for the future. And we've tried to do this with the lighting, with the colors that you see, very calming colors. One of the questions that we get asked a lot is, are there windows in the pod? And you can see here that no, there are no windows in the pod. We've actually done a lot of analysis in this regard, and we've come to the conclusion that it does not make sense from a number of different aspects, technical as well as economic aspects. It doesn't make sense to have windows in the pod, but people are concerned that it will feel claustrophobic or feel like a small space. And what we've actually done here is we've created this skylight, which almost imitates the sky above, and it creates a very calming feeling, despite the fact that actually, there are no windows here. And so these are the types of design decisions that we've made in order to make the interior of the pod feel safe, feel comfortable, and it also feel very familiar to most folks. At the end of last year, we also announced a Hyperloop certification center, which we are very, very excited about. We have partnered with the state of West Virginia to build this roughly 9-kilometer long track with a bunch of ancillary facilities. We've also been talking to the US Department of Transportation and the various regulatory decision makers around how we can use this facility to certify Hyperloop. Our goal is to be safety certified by 2025 with commercial operations by 2030. And with that, I'll leave it to questions. Thank you very much for your time today.
Thank you so much, Diana. It has been a really nice presentation. We have some questions, for example, one from YouTube, and I'm going to ask you. Well, it's a question about the length of the pod. How many passengers can fit in one pod, and why Virgin Hyperloop has decided to go with this number, and why this length of the pod has been chosen and not a longer one?
Thank you. It's a good question because as you can see across different Hyperloop companies, there are various configurations when it comes to the pod and also to the infrastructure as well. 28 is the number of passengers that we can fit into our pod the way it's designed currently. We chose that number after a lot of analysis and a lot of optimization because we believe that one of the main value propositions of Hyperloop is frequent departures. That allows us to carry a lot of people, but it also allows us to be very demand responsive. So what I mean by that is you don't have to wait for hundreds of people to show up before the pod goes. You can wait for 27 other people at most to show up. And so that enables very frequent departures. It enables direct to destination. There are no stops along the way, unlike a more traditional train. And you can do that because actually the operating costs of moving a single smaller pod is quite small compared to the cost of moving, like let's say a larger several hundred passenger train. And so we're able to utilize that to our advantage by providing a better customer experience.
Thank you so much, Diana, for answering that question. And now I'm going to give pass to Kawa and Walter from Aecom. So thank you.
Good afternoon, good evening, good morning, and thanks European Hyperloop for inviting us for this call. And I'm Walter Perry, and together with Kawar, we're going to give a presentation about the involvement of Aecom and Hyperloop. Please let me know when you see my screen.
Yeah, we can see it.
Okay, then I go into presentation mode. Kawar, maybe you can start and then I introduce myself.
Yep, thank you, Wouter. So thank you, Wouter, and thank you to European Hyperloop Week for inviting us and for the opportunity to participate in the Hyperloop conversation. So my name is Kawa. I'm a professional engineer with over 20 years of experience. A short snapshot of my experience takes me back to my days in Edinburgh, Scotland, where I was involved in sustainable transportation solutions that integrated the design and the implementation in a more friendly manner, and with the word living that as we speak. So Walter and I and Aecom are excited to be part of this this initiative and event, and look forward to supporting and working with the European Hyperloop and its partners on this initiative. Back to you, Wouter.
Thank you. And I'm Wouter Perry, as mentioned. I'm a program manager within Aecom, serving clients in different parts of the region in Europe, but also in Americas. And I think as Aecom, we're really happy to connect our global coverage and knowledge with each other, but also with yourself. On the next slide, I'm going to show a short movie about our company and actually our connection with infrastructure and Hyperloop.
Before your day begins, infrastructure is already hard at work. Opening the door to opportunity, to connect, to dream, to rise, to be there when it counts, power possibilities, safeguard the planet, renew hope, and help communities thrive. At Aecom, we're taking on the world's most complex challenges, turning ideas into reality, and building legacies for generations to come. We are planners, designers, engineers, and builders, realizing dreams for a better world. From daybreak to the dawn of something great. Aecom. Imagine it. Delivered.
That's a short introduction of our company, and I think in a nutshell, what's really important for us is that we are actually the connectors between actually the company speaking earlier, Celeros, Virgin Hyperloop, and Novomo, that they really carry the process, the equipment, the knowledge, and are the technology providers, and we have the knowledge to spread this knowledge and to have this infrastructure connected with really building infrastructure projects or Hyperloop projects. And we will tell a little bit more later in the presentation on the projects we worked on. Just Aecom as a company worldwide, we have 56,000 people globally. We are present in all continents and have different type of services. In Europe specifically, we are with 9,500, and we are focused on UK and Ireland and Western Europe, where we have quite big teams on different type of services. Then Kwa, you will continue with a little bit what we do and show actually the type of projects related to Hyperloop.
Thank you, Wouter. And so I just want to kind of build on what Wouter said, that Aecom, despite our size, we're quite a transient staff. We work across globes, across business lines, and I would say that I'm a testament to that. I started my career in the UK, worked in North Africa, and then moved to North America, and have been doing work in the Middle East and far out as Australia. So we have as we say, a very broad and global reach. So you've heard from us on who we are, and I would like to cover what we do and what drives us, and want to make us the preferred consultant or engineering company that our clients come to. So maybe if you go to the next slide. So on this chart, you'll see that we've done quite a number of projects across the globe, reaching about 21, where we provide technical, financial, and construction operational services from North America, Central America, to Europe, Finland, Sweden, to the Middle East, and then to the South Asia and Australia. And we're going to do is just take a few minutes over the next couple of slides, and I'm going to invite Wouter back to describe two particular projects, and I'll touch on the second one.
And one of the projects we're really proud to be involved in is actually connected to a lot of things you have done as students. in the past, the Hyperloop competition was actually organized at the SpaceX test track, and that test track was built by Aecom. We were given order to design, construct, and by that also build this test track in the recent past. Yeah, I think that's really something to. It's a privilege to, as a company, to have worked for such an actually iconic project, and happy to share the knowledge in further detail when required in other presentations.
Thank you, Uta. I just want to start with a statement. I think what everyone's heard. So Hyperloop represents the greatest leap in transport infrastructure for generations, and has the potential to revolutionize our transportation world. We've heard from the technology providers and others on this presentation today. The dramatic change and how that's taking place, and at Aecom, we believe infrastructure creates opportunity for everyone, whether it's improving your commute, keeping the lights on, providing access to clean water, or transforming skylines. Infrastructure powers possibilities to help people and communities thrive. It is through our values that we are proud to support clients, governments, and agencies around the globe. And our values is what really underpins some of our work. From a safeguarding, collaborating, inspiring, anticipating, and delivering on dreams. And this particular project, which I was a project manager on, and the primary author, was a study we did for Transport Canada. It's a preliminary feasibility study of Hyperloop technology, the first of its kind that was completed just last year, and it's available online for those who are interested to learn more about the study. And what I'm going to give you just a brief summary. So this independent study undertook a holistic assessment of the viability and readiness of this rapidly evolving emergent technology for high-speed passenger and freight transportation in the Canadian context. A central objective was to better understand, examine, and determine whether safe, large-scale application of this technology in Canada can be delivered with comparable or lower life cycle costs to existing transportation modes, such as high-speed rail and maglev. The study drew upon a large range of information from public sources, closely working with many of the technology developers, and some of you've heard from today, and industry experts, both internal and external. And we assessed the technology as it's been evolving. And from that assessment, it was very clear and apparent that significant effort and investment reflects the belief that a viable solution is within our reach. This particular slide and some of the findings of what we looked at, covered aspects such as literature review. We looked at many papers, studies completed by governments, by independent universities, and so forth. And we've reviewed the engineering designs and concepts. And I think, as you heard in the first presentation, we're moving towards convergence, and convergence is a key component to this. And then we looked at the technology as it would be applied to Canada, examining the hazards and the risk assessments, conducting reviews of regulations and legislation and how they would fit within that. And then taking the next step is, at a high level, what's the capital and operating costs for implementing these? How would they work? What would be some of the considerations? And then really looking at some of the next steps, and and that's all detailed and can be found in this study, and that's available online. So next slide. So so what drivers? And I mentioned earlier, it's our core values to work collaboratively to safeguard the communities, to inspire and to bring innovation, and to work with partners and technology developers, etc., in unison, as opposed to been at the forefront. Next slide. So one of the key things about why we're here and what we're all about is we are how we are here to support the European Hyperloop Week, and to build a world for future generations that are better connected, both locally and by community, that are more sustainable using new emerging technologies, environmentally sensitive, working with the environment, adaptive, and adaptable to a changing environment or a changing world. So that is what Aecom and what we hope to bring to this conversation.
Indeed, Kwa, and I think that together with European Hyperloop Week, the technology providers, together basically with all of you, I think we believe that we can change this sentence in building sustainable infrastructure for generations to come. And by that, I'd like to thank Kwa, and also thank you for the opportunity again to present ourselves. And I think back to Maria. Thank you.
Thank you so much for both of you for this presentation. Then we have some questions for you. The first one is, what was the main feasibility study carried out in Canada out of the many countries where you had Hyperloop projects?
Actually, it was not the first study. Yeah? We've done several studies, as you might seen, and Canada was one of the biggest studies, one of the most recent we worked on together with Kawar, and that we also published. Some of the studies we've done are not published.
Yeah, and if I just add on to that, so the federal government in Canada had been approached, or at least been communicated with, on this emerging technology as it's been gaining a lot of momentum and rapid pace, and they wanted to have a look at it independently, outside the realm of the technology developers, to really understand the components for themselves and for Canadians, and how it would be adaptable to the Canadian environment. So when I say the first, it's the first in its kind from a comprehensive look, right down to the individual components, as well as a regulatory and costing perspective.
Okay, thank you for making it clear for the rest of the people. Then we have finished all the conferences, so now we are going to do some questions for the end of the session. So I will ask to please all the speakers put your camera on, so we can see each other. Okay, thank you so much. Now I'm going to ask you one question each company during this session, and the rest of the questions that maybe we can't answer during this session, we will answer at the on our blog site. So do not worry if the question you have made it doesn't appear in the session, but we will answer just after this event. So well, the first question is for Celeros. I'm going to read it, Juan. You discussed many different options for different subsystems, such as braking, propulsion, and levitation. What is the best way to create a redundant system in the case of failure? Should there be a balance between infrastructure and vehicle side systems in the case of failure in either?
Thanks for this question. In the end, I was discussing different technologies because it's good to have in mind all the possible options, no? And in that sense, just to summarize, regarding technologies in the infrastructure, it doesn't mean that it doesn't have to have technologies in the infrastructure, but if we minimize these technologies and we have, of course, with redundancy in mind, no? We can have most of the technology in the vehicle, but also have some technologies in the infrastructure that make us have a redundancy. Of course, redundancy is one of the ways to reduce the risk, and in case of failure, and from that side, in terms of safety, we are taking that into account also in the analysis. Thank you.
Thank you for answering the question. Now the next question is for Novomo. So I'm going to ask you, is Novomo's implementation strategy tailored to Polish railways, or it is adaptable to European transportation systems?
It's absolutely adaptable to any European system and also global systems. It's not tailored to any particular market. Of course, it can be adapted when needed, but yeah, it's absolutely not linked to any particular geography.
Okay, so we will see it all around the world.
Hopefully.
Yeah. Now the next question is for Virgin, to Diana. Well, the question is, how does air circulation with a Hyperloop pod works efficiently, especially focus on air filtration during a pandemic? Airplanes have the benefit of recirculating air every 2 or 5 minutes. Has Virgin Hyperloop considered a system that is similar to this one?
Yeah, the way we've designed our pods, and especially when it comes to various safety and health measures, is actually quite similar to the way you think about an aircraft. So the amount of circulation, the amount of air circulation, the amount of oxygen replenishment, and vital fluids and all of that kind of stuff we've actually taken a lot of the expertise from aerospace and utilized it for our system. I think, again, this is one of the really important aspects of making this technology commercial, right? Because we all, have focused so much on making the pod move forward, but understanding exactly how a person and how a group of people will behave in emergency situations, and understanding things that are very important when it comes to life and health and safety and all that kind of stuff. Those are the very reasons why we are engaging right now with regulators to understand how they think about safety, how they think about risk, how they think about the amount of redundancies that are needed in this system. So we've absolutely done a lot of work on this, but this is just the beginning. We will need to continue doing a lot of testing and continue doing development on that aspect.
Yeah, we hope to see all this progress, hopefully. And then for Aecom, some of the attendants ask, how could it be as cheap as a bus ticket? Even regular train tickets are more expensive.
Great question. Not sure yet if it'll be cheap as a bus ticket. Maybe, a few decades down the line when it's more established and evolved, and it's rivaling other modes, particularly aviation. We might see a bigger uptick, but I think quite an optimistic view, in my opinion, at this stage.
Maybe another angle to this answer. I think if you take into account that Hyperloop is a sustainable way of developing and transport, and when you make the cost of a bus ticket or a train ticket or an airplane ticket, and you take all the cost into account from the environment, the impact that you have, the impact that you make, the pollution, then maybe at some point in time it can become comparable. And I think that is the moment that Hyperloop will really flourish, and the moment that these companies will shine.
Okay, thank you so much. And then we'd like to finish this section with a general question to all of you. And is, how do you think that an event like the European Hyperloop Week can help the standardization process of Hyperloop? So I don't know who wants to start, Walter?
Yeah, happy to start, Maria. I think most important is the connection you make. You see it today already. You bring together different really knowledge carriers that connect to each other to make actually in the end one integrated approach. And I think that is really important, and that's what European Hyperloop is doing. Actually, you're proceeding on what has built in the past, and you make sure that we keep this connection. Going back to all the student teams that basically contribute to this, it's also that new ideas, the new knowledge, and that together builds up a brighter future. So that's really the potential of it.
Yeah, and I'll agree with Walter on that. I think this is absolutely a great opportunity for all of us to connect and talk about the technology and the things that we're all very interested in. This is important not just for the standardization process. I mean, it's important for all aspects of moving this industry forward. Standardization is one very important part of it, but also equally important, I would say, is the regulatory framework, how safety is viewed, the various risks that are being analyzed as part of the system, all of these things, and also just on the commercial aspect, right? Understanding how Hyperloop can be utilized, what kinds of city pairs would be connected. Is it going to be for passengers, for cargo? All of these things are still yet to be seen and warrants discussion. And I think this is the great part of that discussion, and we really appreciate having this forum to raise these topics.
Thank you. I don't know if
okay, so maybe myself. I can't agree more from what have been said, especially this aspect of having new, fresh ideas. This is, I guess, totally critical, because all of us have been around in the industry for quite a while. So having any fresh inputs, it's really very important. And from the quality of questions and all the aspects that have been raised today, we can see that there are many people which are very much into Hyperloop. So I think it's a great opportunity, as Diana has said, not only regarding standardization, but in principle many aspects from business development, technical perspective, and we would very much like to see more of this kind of events happening in the future. So thank you so much for organizing this one and inviting us.
Yeah, from my side, it's more or less in line with what everyone is talking. More or less, what I think is that events like this are a platform to drive the debate. Usually, Hyperloop is something. Well, it's not that new right now. It's already more than 5 years, 200 years before it when it started. But most of the people don't know what's behind that, no? And I think you have a powerful tool now with these conferences, just to make sure that everyone is in line, no? And that people understand really the current developments and get excited about what's to come, because we are all really excited to see people moving in a mass scale on Hyperloop. So in that sense, I think you have a very interesting role in that sense.
Yeah, and hopefully there will be more opportunities to see each other in person, not only online, in the coming quarters, right?
Yeah, we hope so, to see each other in a different way, hopefully soon. So thank you so much for answering this question. Also for being here in the webinar, not only for the speakers, but also for everybody that has attended all the event. From the organization, we hope that you have enjoyed the event. If you have more questions, as I have already said, don't worry, they will be answered through the website. And well, with this, I think we're going to close the event. Again, thank you so much for attending, and we encourage you to stay tuned to the news about the EHW and about Hyperloop in general, because well, we are making the future our present. So thank you.
Thank you very much.
Thank you. Bye.
Bye.
Have a good day.
Thank you, everybody.
Bye.